Okay, so yesterday we left off somewhere here on the back of worksheet 8. It says the survey found that 20% of Americans have visited a doctor in the past 6 months. 5 people will be selected at random and asked if they visited a doctor in the past 6 months. Construct a graph of binomial distribution for the random variable x, indicating the number of people who said yes. Okay, that random variable thing always throws people, okay? Just ignore it. Just read it as for the number of people who said yes, okay? So if we are asking 5 people, we could have 0, 1, 2, 3, or 4, or 5 say yes, they have visited the doctor in the past 6 months, okay? So this is a binomial probability because it's success or failure. It's either yes or no, right? So if we were doing this on the calculator, well, let's do one by hand here. Out of 5 people, what's the chance that none of them have visited? The probability that they visited was 0.2, so we want none of them to have visited, and 0.8 that they won't have visited, and all 5 to have not visited. Probability of success and failure, we remember this from yesterday, okay? And we also did that as Binom PDF, and from the reference sheet, too many slides here. Thought I could get there faster this way, but apparently this wasn't a good choice. Right here, Binom PDF, and it's N. What does N stand for? Right over here, it says number of trials, right? Comma P, which is probability of success, comma X, which is the number of successes we want to have. And it's under the distribution menu. Okay, let me fly back to where we were, I think is here. So we would put, for this first one, we'd put 5.2 and 0. I don't know what that is. It's not a 0. And then we would change this to 1, 2, 3, etc. All right, so on the calculator, it's under second vars. And then we go to choice A, Binom PDF. Again, it was 5.2, and we were starting out with 0 people going to the doctor. And we got 0.23768, which they rounded in the chart to 0.238. Okay? They kept going, did all the way through 5. So then it said, this is the probability distribution table that they asked to do. And it said find the probability that at least 4 people say yes. At least 4 was either 4 or 5. So we did the probabilities and added them together, which if you did it in the calculator, I think you get a slightly different number. Let me see if I can do this really fast. If we do 4 plus, no, let's just do it separate. Okay, 4 and 5. And then if we add those together, we get 0.0672, which is pretty close to what they had. It's a little bit higher, okay? So about 0.7% that we would get 4 or 5 people to say they went to the doctor out of the 5 we asked in the last 6 months. Okay, so we're supposed to do this. Number 4 says the survey found that 60% healthcare fraud were senior citizens. 6 victims of healthcare fraud will be chosen at random. So what does that tell us? Our sample size is 6. Will be chosen at random and their ages will be recorded. Construct A binomial distribution, we're not going to bother to graph it. For the random variable representing the number of senior citizens chosen, okay? So it's yes or no, are they a senior citizen? Everybody got it? So 60% are senior citizens. So there's a 60% chance they will be, and the chance they won't be would then be 40%. Everybody good? Okay. So we're asking 6, so this could be painful. We have 0, 1, 2, 3, 4, 5, or 6 of them said they're senior citizens. All right. How fast can we do this? Can some of you start at the bottom, and when I get partway down, you can tell me what the numbers should be? 6. What was it again? 0.6? Okay, if I start with 0, get 0.004096. I don't really need that many decimal places. Change this to 1 of them being a senior citizen would happen more often. Anybody start at the other end and have numbers to read me yet? Excellent. Let me get 3 in here. 0.2765. Okay. I don't care how many places. Go ahead. Okay. Okay. Now it says thank you. Find the probability that at least 3 of the victims will be senior citizens. At least 3 means all of these count, yes? Everybody good? At least 3 would count 3, 4, 5, and 6. So we need to add all those probabilities up. About 6 something. Anybody add those up? Patsy, this is for you. 0.82. Okay. I can show you one more time how to use that combined probability. What do we not want to count, guys? We don't want to count what? 2 or below, right? And that combined probability counts down. It adds down the percentage. So you would have to do Binom CDF, 6 trials, 0.6, and the upper limit is 2 that we don't want to count. So you'd say, do all those, and you get 0.1792. Those are the ones we don't want to count. So then what would we have to do? 1 minus that, and we get 0.8208, okay? If you're in AP Stats, you're good with that. If you're not, that CDF is complicated. All right. Mr. Hanlon distributed 5-question quiz to his students. There are 5, someone get the door, 5 choices for each question, guesses on each question. What should get exactly 3 right? Okay, how would we do that? Exactly 3 right. Okay, we can use Binom PDF. What is our sample size? 5 questions on the quiz, right? The 5 choices means the chance of being correct is 1 in 5 success, right? So that's P. And what do we want to get exactly right for this choice? 3 questions. If you're not doing this on your calculator, I have one thing to say for you. Don't ask me later. .0512, anybody? If you want to move it over and make it 5% or 5.1%, that's fine, but then you got to have the percent symbol, okay? What would be the probability in part A if there were only 4 choices? So what are we going to change? This is different. We're going to change the probability of success to what? 1/4. But otherwise, the rest of the question stays the same. A bit easier just to retype this, I think, but there we go, 1/4. I got 0.088 if I, does that seem about right? About 8.8%. Anybody else get that? Okay, what would be the probability, same question, of getting 3 right if it was only true false? We could change the 1/4 to 1/2. Is there another way we could do that? Okay. We could figure it out another way, but it'd be more complicated probably than just leave. So I'm just going to leave it. All right, expected value. We good on binomial probability? And because this is not a probability class, I will make it clear that it's a binomial probability question on the quiz. Does that make sense? I'm not just going to lump it all together and say, pick which one you should use this for. All right. Expected value of a random variable for probability distribution is equal to the mean of the random variable. Okay, that sounds all complicated. Here's an example. At a raffle, 500 tickets are sold for $1 each for 3 prizes. There's a $100 prize, a $50 prize, and a $10 prize. What is the expected value of your net gain if you buy a ticket? Okay. If you are one of the 497 losers, how much do you lose? Does everybody see why I got 497? Because there's 3 people are going to win something. 497 people are going to lose how much each? $1 each. Somebody's not going to win $100. What is one person going to win, actually? 99, right? Their net winnings are going to be 99. And 49 and 9, because everybody had to buy a ticket. Okay. So expected value is the $99 will be 1 out of the 500 people. That's where that came from. And then $49 will be won by 1 out of the 500 people. $9 will be won by 1 out of the 500 people. And the other 497 out of 500, which is this number, will each lose $1. Okay? If we add that all up, it's negative 68 cents, which means the expected value or the average loss someone's going to, if you put everybody in a pool, the average loss per person is 68 cents. Okay? Now, can anybody actually lose 68 cents? No. This is just the average for all of the tickets. Okay? So it says an expected value is not an indication of how much a single person might lose, because you can't do that. Okay? It's the average for everybody. All right, we're going to try this question. A water park makes $350,000. Do you have this one or not? Makes $350,000 when the weather is normal and loses $80,000 per season when there are more bad days than normal. The probability of having more bad days than normal is 35%. Find the park's expected profit. Okay, so 35% of the time, there's more bad days than normal. So what happens? They lose 80,000, so we'd multiply that by negative 80,000. Okay, the rest of the time, they make 350,000 in a season. Whoop, one more zero. Okay, we need a percentage. Everybody's good with where that comes from, right? The chance of a good season is 65%. All right, that's it. Add it up, see what you get. I did something wrong, I think. Oh, that's what you got? Okay. I thought that said 35,000, so then I was so confused how it could be that much, but no. So what this is saying, expected profit of this much for the season. So can they actually make this exact amount? Not necessarily, right? But if we were to say, run this water park for 100 years, this is their average profit. Okay? All right. Moving on, you have this number 6. A resort is planning a bicycle race. The cost of sponsoring the race is $8,000. So they're out the $8,000. Okay? The resort expects to make $15,000 on the event. I'm going to count that as profit to the clear, okay? Above and beyond the amount they spent here. There is a 30% chance of a hurricane arriving the day of the race. If this happens, the race will be canceled and not rescheduled. What is the resort's expected profit? Okay. So 30% chance that what happens? Hurricane, which means they will lose $8,000, yes? Okay. On the other hand, there's a what percent chance? 70% chance that they will actually make back their money plus the profit of 15,000, okay? It says expects to make, so I'm going to assume that's beyond the cost, okay? I would make that clearer in a question on a quiz. All right, so type that in, see what you get. I don't want to use the online one, it takes too long. This number can be negative and it can be positive, guys. If it turns out negative and you're the owner of the resort, what are you going to do? Yeah, I'm going to say we're canceling, right? Because I'm expected to lose money. I got this. Did someone else get that? Okay. So this is an average. If it was always 30% chance that the day of the race, okay, on average, they would make a profit of this much. All right. Number 7, an insurance company insures a painting worth $20,000 against theft for $300 a year. The company has assessed the probability of the painting being stolen in a given year as 0.002. What is the insurance company's expected annual profit? Okay, we're the company. All right. So, as the company, we make $300 how often? Every year. But what is our probability that we don't have to pay out? This is the probability that's stolen and we have to pay it out, right? 1 minus is 0.998. So 99.8% of the time, we just get $300 from these people and we're in the clear. All right? But 0.002% of the time, what happens? We have to pay out $20,000. Now, it isn't going to make a huge difference in our answer, but in order for us to have to pay out $20,000, they had to have given us the $300, right? So we would really only have a net loss of $19,700. Is that right, guys? Okay. It wouldn't make a huge difference in our final answer if we forgot that part on this question, but yeah. I got $260. Did anybody? Okay. So expected annual profit of $260. Okay. So if we insured this painting for 100 years at this price, we would expect to make $260 a year roughly on average. Okay. I'm thinking insurance uses this a lot, right? This kind of an idea. All right. Suppose we hold a fundraiser and we sell raffle tickets to win a TI 35 worth $15, or a TI 83 worth $45, or a TI 84 worth $100. One of each will be given away. If we sell 50 tickets at $1 each, find the expected value of a ticket holder's net gain or loss. Okay, so a bunch of people are going to lose $1. Yes? How many of people are going to lose $1? 47 out of 50 people, right? Okay, then what else is going to happen? One person's going to get the $15 calculator. So 1 out of 50 is going to make how much, though? If it's a $15 calculator, they actually only make $14 because they still had to buy a ticket. Okay? 1 out of the 50 is going to make $44 for the $45 calculator, but they had to buy a ticket. And 1 out of the 50 is also going to make $99. Someone else get 220? Okay. So the question is, my question, is this a good raffle to enter? Because your expected average value is positive, right? Now, it doesn't mean you're necessarily good. There's still 47 people who are going to lose $1. But if I were selling 800 tickets, do you think the expected value would be positive? Right? If I changed this all to, what would it be? 797 out of 800 and 1/800th and 1/800th and 1/800th. Okay. Then you'd lose money, right? You're expected to lose money because only the probability of you winning is so small, and even what you win is not much. All right. So that was the end of the lesson from yesterday. So now you can do worksheet 9 that has expected value stuff on it, okay? Yeah. All right, I am moving on to worksheet 10. And some of this we already covered. We already talked yesterday about mean, median, mode, standard deviation on the calculator. So we need to talk about symmetric and skewed distributions of data, okay? Negative or left skewed distribution of data means the mean, the average, is less than the middle number. The majority of the data is on the right and the tail extends off to the left. Okay, so basically I'd give you a picture of one of these choices and I'd say, is this data something similar to this anyway? Left skewed, right skewed, or symmetric? Or none of the above, okay? So when the tail is off on the left and most of the data is to the right, it's screwed up on the left is the way I remember it, okay? Symmetric means that both sides of the data are the same. Now, it doesn't have to look like this to be symmetric, okay? It could be that both outsides are up and the middle is low, as long as the mean and the median are about the same. Okay, positively skewed distribution means the average is higher than the middle because there are more low numbers, so the tail is stretched out to the right. Okay, the probability is better, or the whatever is better, that it would be lower. The average is higher. There's some extreme values out here on the right. I don't think I said that right part of that sentence, but anyway. Okay, when a distribution is reasonably symmetrical, the mean, median are close together. In a skewed distribution, however, the mean is located closer to the tail than the median. Outliers, which are extreme high or low values, we're going to talk more about outliers, okay, will cause the mean to drift even further toward the tail. The median is less affected by the presence of outliers. Guys, this is why when they report in the paper the average price, average value of a home sold in Rockford, we'll say, okay? They used to report this every month. They probably still do, I don't know. Okay, in the realtor pages and the, you know, where they look up if your home values, okay, for homes for sale. They don't report the mean, they report the median. Because if you sell 5 $50,000 houses and $1 million house, and you do a average or a mean, okay, you're going to get like, I don't know, $800,000 or something. Maybe not that high. Doesn't matter. But the average home definitely did not sell for that, right? If you sold 5 $50,000, the median would be $50,000, right? The middle, because you had 6 houses sold total, 5 of them were $50,000. So it just, they report the median because it's not skewed by an outlier. So they're saying half the homes were above this and half the homes were below this amount. That's a bet. When there's an outlier, that's a better predictor or a better number to report. It's called resistant static, or a statistic, or a non. The mean is a non-resistant. In other words, it'll move. We're not going to have to know that vocabulary. Okay. Since standard deviation measures the spread, this statistic is also non-resistant. Okay, can change. So it says when choosing measures of center and spread, this is what you do need to know. If the distribution is reasonably symmetric or free of outliers, you should use the mean and standard deviation. Okay? If it is skewed or has strong outliers, you should report the 5-number summary. And that's what I'm going to ask you, okay, to do. So you already have this, right? And it says this on your paper. If it's reasonably symmetric, use the mean and standard deviation. Otherwise, a 5-number summary is better. Does it say that on your paper? Okay. Here's a set of data, and we are not typing these bad boys in the calculator. That would take the rest of the hour, okay? They put all these in. We are going to do a histogram in a minute, okay? They made a histogram, and we're going to talk about how you can set the values of the scale to choose how wide your bars will be. But this is what it looked like. And I don't have a better picture, but obviously not symmetric, right? Okay. Which kind of skewedness is this? Okay. It's positive or right because it's screwed up on the right. Most of the numbers are off on the left. Yes? All right. If it is right skewed, then we are supposed to use the 5-number summary. And the 5-number summary is under one variable stats. Yesterday, did we scroll down further past the mean, median, mode, or the mean and the standard deviation? Okay. Down below there is where we're going to find this 5-number summary, and it's going to look like this. Minimum, the Q1, which is the 25th percentile, the quartile, the median, Q3, which is the 75th percentile, and the max. All right, but we're going to do that for this question because it's shorter. All right, so quickly type these in. Stat, enter. We want it all in one list. So clear out everything else. Make sure you're in list 1. These are weights of steaks. They're advertising a 20-ounce steak, and they're not all 20 ounces. It says he advertises a 20-ounce sirloin steak on his menu. I believe this is also 20 items, isn't it? Okay, there's 20 steaks that they weighed. I don't think the average is going to come out 20, do you? There's a couple above 20, but most are below. So, all right, we are going to, you ready to try this? Okay, we're going to do a histogram of this data so we can look and determine if it's skewed or not. So we're going to turn on a plot, second y equals. The one we want to pick is the one that looks like a bar graphy thing here. So make sure you click so it says on. Then arrow down and arrow to the right till you're on that one. Now, you have to have list 1 here, but you also have to have a 1 here for frequency. Everybody good? Make sure it's on. Now, if you go to y equals real quick, whoops, go ahead and go to y equals. Make sure you don't have anything else typed in there, okay? And you're going to want to be on function mode. And then how do we do a zoom so that we can see this? Do you remember? Yeah, we want to do the stat one so that we can see, which is zoom 9. Now, I don't like this window, but there it is. Okay. Yeah, I'm not sure. This is what I got the first. No, it's not. Did I put something in wrong? I think I put something in wrong when I did it earlier because it had a window of 31. Everybody else's look like this? Okay. Yeah, just did you go to the list to make sure you didn't type anything wrong? You good or not? Were you? Oh, All right. If you go to window, guys, this would have not been my choice. They went from 17, everybody paying attention because this is important, 17 to 21.8. They counted the width of each bar by 0.8. So if you go back to your graph and you trace, this bar represents 17 to 17.8 ounce steaks. That's kind of weird, huh? What if we went back here, we could change this scale to what, maybe? Just to 1. Now if you go to the graph, it looks slightly different. But is it still kind of skewed? I guess so. I'm going to change this to 22. And apparently I'm going to keep choking. I think I'm going to do one more thing. I'm going to go ahead and calculate the one variable stats, because that's what we're going to have to do no matter what. So go stat, right arrow, one variable stats. Make sure you don't have a frequency list. So if you have an older calculator, you just hit enter. Okay, the mean is here, but if you scroll down, here's the numbers that they want for the 5-number summary. So my question is, are the mean and median far apart? No. The mean and median are not far apart at all, so I would say it's really not very skewed. Okay. I would take either answer on this one. And I don't know what I did. I must have typed stuff in, because I tried to do this question ahead of time and it's a hot mess. Because the mean and median are so close together, if we said it's not really skewed, then what would we report? Do you remember which one it is? It would be the mean and the standard deviation. Okay. Which were what? 19.3 and 1. So the average steak weighed 19.3 ounces, with most all of the steaks being within 1 of that. Okay. But should he be averaging that he sells a 20-ounce steak? Probably not. He's pushing his luck, right? I think you're right. And the other issue is when they report a 20-ounce steak, it's before they cook it. So you have no way of knowing what it weighed before they cooked it, unless they brought it out to you raw and let you weigh it. Just for the sake of, so how many of them were actually 20 or more? 8 plus 2 that were 22 or 21. So 10 of the 20 actually weighed that much, right? But half of them were below that. All right, so he can probably get away with it, but all right. A uniform distribution is when all of the numbers, all of the categories have exactly the same. The mean and median will also be, so this is a kind of symmetric, okay? Just called uniform because they're all the same. Distributions of data are not always symmetrical or skewed. Sometimes they fall into clusters, okay? You can have a whole bunch low or a whole bunch high, etc. Then it's known as bimodal. We're not going to do a bunch of stuff with that, okay? So this is bimodal because it says cost of tuition for a sample of 20 colleges, okay? Why might that be? What would cause the cost of tuition at 20 colleges to lump into 2 completely different Yeah, I would say like public, state, like not out of tuition, and up here would be your private colleges, right? Going to lump together and be a much higher tuition. All right. It says cluster 1, they did them separately. Okay, we're not going to worry about this. Box and whisker plot. We're going to spend 5 minutes on this. When you do a box and whisker plot, you know what? I'm going to go to this. I have a really quick little slide here, okay? Making and understanding a box and whisker plot. How many of you have done these before? Everybody should have done these at some point, even back in elementary or middle school. But a box and whisker plot, the middle of the box is the median, okay? Q1 is the left end of the box, and Q3 is the right end of the box. This is the minimum value, and this is the maximum value. Okay? What does it mean that this end of the box is longer than this end? It doesn't mean there's more numbers in here. It doesn't mean there's more, it just means they're more spread out. Okay, the data in this quartile, this 25%, is more spread out. So what is the median? 55 Q. Okay, I kind of covered all that. Yes. What is the range? We could find that by doing max minus min, right? All right, so when you have something like this, okay, the left whisker is longer, so the median is closer to here, so this is negatively skewed or left skewed. Symmetrical means when all the pieces are about the same size. When the right whisker is longer, okay, and the median is closer to the left, then it's positively or right skewed. Oh, that's a good question. This one, I would say not. Because this is still right in the middle of these. Okay. So I would probably say not. If both the whisker and the longer box were on the same side, then yes. That's a great question, though. All right, so we will pick up with those tomorrow. This is exactly how far Abruzzo got. I thought I would get further, but no. Okay, so we'll start with box and whisker tomorrow. And then we will move on to percentiles and what else we got tomorrow? Starting normal distributions. Yeah, I don't know if we'll get that far, but we'll do normal distributions Friday if we have to. We'll be good. All right, so worksheet 9, homework tonight. Everybody good? Worksheet 9, A and B.